Good afternoon, I am Mr. Ish. Thank you for joining me for this video where we are examining the difference between molarity and molality by means of this question. We have a hypothetical glucose solution which has a density of 1.2 grams per milliliters. If 40 grams of glucose were dissolved to generate that solution, we have to find the molarity and molality if the total volume of that solution was equal to 1000 milliliters. How do you go about doing this? Well, understand molarity is equal to moles of your solute divided by volume of your solution. So you have to keep that in mind. The molality is slightly different, which is symbolized as a lowercase m is equal to moles of your solute, which is not hard to determine here, but it's divided by kilogram of solvent, not solution, but solvent. And you have to remember the solution here, in terms of the grams of the solution, grams of solution is equal to grams of solute plus grams of solvent. You have to remember all of these items coming into play. We have here a total volume is equal to 1000 milliliters, which is 1 liter of solution. We have 40 grams of glucose. What's our moles of glucose? Well, we know it's 40 grams. We know that the molar weight or the molecular weight, the molar mass of glucose is 180. Divide them. 40 divided by 180. You get here 0.2222 repeating, which you can just do like that. 0.22 moles of glucose. Let's look at the molarity first, because you have everything here to do your molarity calculation because it's easy. Molarity is equal to 0.2222, which you can just say is 2 or 9, because that's indeed equal to 0.22, repeating 2 or 9 moles, divided by your total volume, which is 1000 milliliters, but it has to be in 1 liter. You have to convert into liters. This is equal to right here 0.22 molar. That's our answer right here. The molarity is equal to 0.22 repeating molar, and we'll put this aside. The majority of the time we'll spend now in determining the molality. The molarity was easy, we've done that. Now for the molality calculation, we already have the moles glucose, which is fine, we'll use that. But we need to determine the kilogram of solvent. Given the total volume, we have 1000 milliliters, and given the fact that we have a density 1.2 grams divided by 1 ml, we're now looking at 1200 grams of solution. But you have to remember what I have over here. Grams of solution is equal to grams solute plus grams solvent. If I minus from this the grams of solute, what is that grams of solute? It's 40. What do I have? I have here a 1160 grams of solvent, which you convert into kilograms, which is 1.16 kilograms. And now you have everything in play for your molality calculation, which will be this 0.22 moles, which I'll just say as 2 or 9 divided by 1.16 kilograms. 2 or 9 moles of solute glucose divided by 1.16 kilogram of that solvent, and we'll have our final answer. 2 divided by 9, which is 0.22 repeating, divided by 1.16, and our molality is 0.19157, which I will round up to 0.1916 moles. And that's my answer. 0.222 molars and 0.1916 moles. So we've determined the molarity and the molality, and you can see what the difference is between the two, very much represented here by the denominator of these two formula, volume in liters versus kilogram of solvent. And you can see how the density came into play over here. Have a good day. Bye.